Okay, so we're going to look at some indices questions, and there are a number of basic rules of indices that you need to learn, and we'll build those up as we work through these questions. So the first question that we've got there is w to the power of 4 multiplied by w to the power of 5. Now, the first law of indices for you to get your head around is that if you're multiplying two expressions together with the same base, that is the bottom part of it, so w is the base there, that's also w, but when you multiply them it means that you can add the powers together. So that's the first one. So if you've got x to the a times x to the b, then the result of that is the same as x to the power of a plus b. So that's the first law, and that means that this particular question you're going to have w to the power of 4 plus 5, which is 9. Okay, the second one, here we've got some division going on, so we've got 12a to the 7 b to the 4 divided by 4ab cubed, and this leads to the second law that we need to use, which is if you're dividing bases that are the same. So if you've got x to the a over x to the b, then that's the same as subtracting the powers. So that's the same as doing x to the a take away b. Now in this one, what that means, you deal with the numbers as they are, so that means 12 divided by 4 is 3. Then what we've got here, if there's no power, then that means that there's a little 1 there and we don't need to write it in. Okay, so what we've got is a to the 7 take away 1, which is a to the 6, and then we've got b divided by b, so subtract their powers, 4 take away 3 is 1, which you can write as just b or b to the 1. Either way, it doesn't matter, you'll get the same, you get it marked right either way. So if you're multiplying and the bases are the same, you add the powers. If you're dividing and the bases are the same, then you subtract the powers. So that takes us now to question 3, which is 24x to the 12. So question 3, 24x to the 12 y to the 6 all over 8 x to the 4 y to the 8. Zoom in a little bit. Okay, so 24 divided by 8 is 3. X to the 12 divided by x to the 4, subtract the powers, will be x to the 8. And with this one, what's going to happen now is you're going to have y, and you're going to be 6 take away 8. Okay, let's just do this in 2 stages so you're aware. The top number is smaller than the bottom number, which means that that's going to end up being negative. So what you're going to end up with is 3x to the 8 y to the negative 2. So that's number 3. Number 4, 2x cubed y squared all to the power of 4. So we've got another law of indices here, which is if you're raising a power to another power, so if you've got x to the power of a, and that's all to a different power, then the result is what you get if you multiply those two powers together. So that's going to be a times b. So when you're raising something, a power to another power, you multiply those powers, those indices together. So what that means here is that we're going to have 2 to the power of 4. We'll come back and evaluate it later. X to the power of 3 times 4. And y to the power of 2 times 4. So 2 to the power of 4 is going to be 2 times 2 times 2 times 2. 2 times 4 is sorry, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 2 to the power of 4 is 16, x to the power of 12, y to the power of 8. Question 5. 3y to the power of a half multiplied by 4y to the power of 3 over 2. Now, fractions actually mean something else, but we don't need to worry about it at this particular point. What we've got here then is 3 times 4 is 12. The base is y, and then we're going to add half and 3 halves together. Okay, and when you're adding fractions, you can't add them unless the denominators, the numbers on the bottom, are the same, which they are here. And then you can add what's on top. So we've got 4 over 2. Yeah, 1 half and 3 halves is 4 halves, and 4 halves is the same as 2. So that simplifies to 12y squared. Question 6. So question 6, we have 6x to the half divided by 3x to the minus a half. Okay, so the dividing rule, here's my little list of rules. When you're dividing, you subtract the powers. So where we have to be careful here, 6 divided by 3 is fine, that's 2. And then we're going to have x, and then it's going to be a half, take away, and that's already negative. Minus, minus makes it a plus, so that's the same as 2x to the half plus a half, which is going to be 2x to the power of 1. Okay, so be very careful. If you've got a negative on the denominator in the bottom half of the fraction, then that means that you've got the take away because it's divide, and you've still got that negative half there to deal with. Number 7. Express 9 to the minus a half as a fraction. Okay, so the next couple of laws that we need to deal with here are if you've got roots, okay, if you've got a square root, for example, which is the one that you're most familiar with, it hasn't got a little 2 outside, but you could have a little 2, you could write the little 2 there, then to turn that into index form, into a power, then it would be a fraction. So a square root would be the same as x to the power of a half. A cubed root would be the same as x to the power of a third. So if you've got the nth root, any number, then that would be 1 over whatever that number is. If it was a fifth root, it would be 1 over 5, and so on and so forth. The other thing that we need to deal with before we can answer question 9 is that negative sign there, which also is a message from indices. And that is, if you've got 1 over x, then that can be written as x to the minus 1. Okay? Remember that x to the power of 1 is there, but we don't write it in. In order to get rid of the fraction, we can take the power and make it negative. So if it had been 1 over x squared, then that would have been written x to the minus 2, and so on. So if we come back to look at what we've got here, there's 2 pieces of information that we've got in that power. The first one is that we're dealing with a square root. The 1 over 2 tells us it's the square root. So that's the same as the square root of 9, and then leave that negative there for a minute. I know that the square root of 9 is 3, so that's the same as 3 to the minus 1, and I know that that minus means 1 over. Okay, so the fraction there with the 2 means it's a square root. You don't write the little 2. If you look in your calculator, it's just a square root. but it could be there. So square root of 9 I know is 3. Then I've got that minus 1 to deal with. The minus tells me it's 1 over to give me 1 over 3. Question 8. 2a to the 5b squared times 3a cubed b. Okay, deal with the numbers first. So I've got 2 times 3 is 6. I've got a to the power of 5 times a to the power of 3. So I'm going to add their powers to give a to the power of 8. And then I've got b squared. Remember, if there's nothing there, it means there's a 1 there. So that's going to be 2 plus 1 is 3. Number 9. 3x to the power of 5 y squared all cubed. Okay, so you're raising the power to the power, so this is where you multiply. So you can have 3 cubed from the first bit. Then from the second bit you're going to have x to the power of 5 times 3, and then you're going to have y to the power of 2 times 3. 3 cubed is 3 times 3 times 3. 3 3s are 9, 9 3s are 27. 5 3s are 15, 2 3s are 6. Okay, if you're not sure what I've done to go from there, that means 3 times 3 times 3. 3 times 3 is 9. So those two bits there are the 9, and then 9 times 3 is 27, which is what I've put there. Okay, so 3 cubed, 3 times itself 3 times. Number 10. 24a to the 5 over 2 times a to the minus a half divided by 8 times a to the 4. Okay, 24 divided by 8 is 3. That's easy. Then we've got these here, which are all the same base, which means I can apply my laws of indices. So it's going to be a to the power of 5 over 2 plus minus a half, because they're being multiplied, so I'm going to add them, minus a to the 4. So minus 4. Okay, just make that clear again. The top two are being added, so it's 5 over 2 plus that power, which is minus a half, and then take away, because that's divided by 4. So let's deal with that fraction. What I've got is 5 halves plus minus, that's the same as a take away. So that's going to be 5 halves, take away 1 half, which is 4 halves, take away 4. 4 halves are the same as 2, so that's going to be the same as 2 take away 4, which is negative 2. Click through that again. 24 divided by 8 is 3. All of the other bases are an a, which means I can combine the 3 indices that are there. 5 over 2 plus that one, because they're multiplied together, and then take away that one because it's being divided. The plus and the minus become negative because the signs are different. That's the same as 5 halves take away 1 half. 5 halves take away 1 half is 4 halves. 4 halves are the same as 2. 2 take away 2, negative 4. Sorry, negative 2. Question 11. 5x cubed all squared. Okay, so these aren't necessarily in order of difficulty. We've done a few like these now. What we've got here is 5 squared and then x to the 3 times 2. 5 5s are 25, x to the power of 6. Question 12. 4x cubed y squared times 2x4 y5. Okay, so we're multiplying. Okay, all the brackets are doing there are just separating the two terms that we're multiplying together. So what we're going to have is 4 times 2 is 8, x cubed plus 4, because we're multiplying, so we're going to add those powers, and then times y, 2 plus 5. 8x to the 7, y to the 7. Okay, you could write multiplies in between there, alright, you're multiplying them, but as you know in algebra we don't tend to write those multiplies in. Number 13. Find in its simplest form the reciprocal of 3x to the minus 2. Now reciprocal means 1 over. Okay, so the reciprocal of 2 reciprocal of 2 is 1 over 2. The reciprocal of 10 would be 1 over 10. The reciprocal of a half, well, that's the same as 1 over a half. You would turn it upside down, which is 2. Okay, so that's what a reciprocal means. So if we've got the reciprocal of 3x to the minus 2, that means 1 over 3x to the minus 2. Now, we can't do anything with the 1 over 3, but the x minus 2, we can, I wonder if I can do this another way. If we think of it, rather than 1 over, rather than write it like that, if we write it as the power of minus 1, then the reciprocal of 2 is 2 to the power of minus 1, and 2 to the power of minus 1 is a half. The reciprocal of 10 would be 10 to the power of minus 1, which is 1 over 10. The reciprocal of a half would be a half to the minus 1, which would be 1 over a half, which, as we said there, is 2. So if we think of this like that, then what we're going to have is 3x to the minus 2 to the minus 1. Remember, when we're raising a power to another power, we're going to multiply. So what we get now is 3 to the minus 1, x to the minus 2 times minus 1. 3 to the minus 1 means 1 over 3, and this is going to be minus times a minus makes a plus. 2 times 1 is 2. So the simplest way of writing the reciprocal of 3x to the minus 2 is 1/3 x squared. Okay, so quickly go through that. Reciprocal means 1 over, or to the power of minus 1. So the reciprocal of 2 would be 1 over 2 is a half, 2 to the power of minus 1, which is a half. If I was doing the reciprocal of 10, it would be 1 over 10, but I could also write it as 10 to the minus 1. Reciprocal of a half, 1 over a half, which is 2. Or I could write it as half to the minus 1. So to write down the reciprocal of 3x to the minus 2, it would be 3x to the minus 2 all to the power of minus 1. Then I can split it up. 3 to the minus 1, x to the minus 2 times minus 1. 3 to the power of minus 1 is the same as a third, same as what we did up there with the reciprocal of 2. And then minus times a minus makes that plus x squared. Question 14. So there's two parts to question 14. Simplify each of the following. So we got 16 to the power of 3 over 4. Now, if you remember what we've got here when we're going through these standard ones, is that this is giving me a message here that that's the fourth root of 16. Okay, so that is the same as the fourth root of 16, and then we've still got to cube it for the number on top. Now the fourth root of 16, what you're saying is what times itself 4 times makes 16. And it's worth you knowing what 2 to the power of 1, 2 squared, 2 cubed, 2 to the 4 is. And the same with 3, 3 squared, 3 cubed. They're standard ones, and it's likely to be one of those that will come up. So if we go through those, 2 to the power of 1 is 2, 2 squared is 4, 2 cubed is 2 times 2 times 2, which is 8, 2 to the power of 4 is 8 times 2, which is 16. You should know those. Similarly with 3, 3 to the power of 1 is 3, 3 squared is 9, 3 cubed is 27. You're unlikely to need 3 to the power of 4, but it's 81. So you should know those relationships. So what this is saying is what number times itself 4 times is 16? And the answer is 2. Okay, so that's going to be the same as 2 cubed. Okay, the bit inside the bracket there is 2, and 2 cubed, I know, is 8. And then B, 9 to the minus a half. Well, again, what that's telling me is I got the fraction there telling me I need the square root of 9, and I've got that minus 1 there to deal with after. Well, I know the square root of 9 is 3, and I know that that minus 1 is telling me to put it as 1 over. So deal with the 2 bits of the fraction. They're giving you different messages. The bottom bit is giving you a root. Square root of 9 I know is 3. Then I've got to deal with the top part of the fraction, which is negative 1. That's telling me it's 1 over. Number 15. Right, this is slightly different. Okay, given that x is a number between 0 and 1, write x, 1 over x, and x squared in ascending order. So the easiest thing to do here is just choose a value of x to start with. And you can't get a more straightforward number between 0 and 1 than a half. Okay, so if x is a half, then 1 over x would be 1 over a half, which we covered in an earlier question is 2, and x squared will be a half times a half, which is a quarter. So in order of size, the smallest value there is a quarter, so the smallest is going to be x squared. Then you're going to have the half, which is x. Then you're going to have 1 over x. Okay, so choose a value for x. If you're working between 0 and 1, then the simplest value is going to be a half, and then work out what happens to the 3 expressions, then put it in order. So there's your order going up from the smallest, which is x squared, to the largest, which is 1 over x. And that's will only be the case between 0 and 1. If it was a value of x bigger than 1, then that order would work out differently. Okay, question 16. So this is a straightforward one. 4 c to the 7 d cubed times 3 c to the 4d. Numbers, multiply, 4 3s are 12. The bases c, add the powers together, so it's going to be 7 add 4, which is 11, and d, 3 plus, remember there's a 1 there which you don't write, so that's going to be 4. Number 17. 4 x to the 5 y squared to the power of 3. We're raising a power, so we're going to be multiplying. It's not 4 times 3 though, it's 4 to the power of 3. because there's a 1 there that we don't write, so it's going to be 4 to the power of 1 times 3. We'll come back and work out what 4 cubed is in a moment. And then we're going to have x to the power of 5 times 3 is 15, and y to the power of 2 times 3, which is 6. 4 times 4 is 16. 16 times 4 is 64. So that works out to be 64, 15, x to the 15, y to the power of 6. Number 18. 18 times a to the 5 over 2 times a to the minus 3 over 2, all divided by 6, a squared. 18 divided by 6, straightforward, 3. Then we've got the same situation as we had in an earlier question, where all the bases are the same, so we can combine the powers. So we've got 5 halves, plus minus 3 halves, take away 2 for the divided by a squared underneath there. Simplify that further. The plus times a minus is a minus, so that's the same as 5 halves take away 3 halves. If you've got 5 halves, you take away 3 halves, you're left with 2 halves, take away 2. 2 halves are the same as 1. 2 divided by 2 is 1. So we get 3, 1, take away 2, which is negative 1. So that simplifies down to negative 1. Go through that again quickly. 18 divided by 6 is 3. All the other parts of that have got a base of a, so we can combine them. 5 over 2, then we add because we're multiplying, but we're adding that negative number, and then we're taking away 2 because we're dividing for that one. Then we're tidying up fractions. 5 halves take away 3 halves, because plus times a minus is a minus. 5 halves take away 3 halves, leaves you 2 halves. 2 halves is 1. 1 take away 2 is negative 1. Number 19. 25 to 0.5 times 10 to the minus 2. Right. Well, 25 to the 0.5, they've been a bit cheeky here. We know that 0.5 can be written as a half. And we know that if it's a half, that's giving me a message there, and the message is that that's the square root of 25. And I know that the square root of 25 is 5. So I've got 5 times, and then 10 to the power of minus 2. Well, 10 to the power of 2, I can write like that, and I know then that that's 100. So I got 5 times 100 to the power of minus 1. I know that the minus 1 is sending me a signal, which means I can put it as 5 times 1 over 100. Sorry, lost the whole sum. That's the same as 5 over 100. And 5 over 100 is the same as 1 over 20. Okay, so I mean, I've gone through lots of stages there. You could take any number of shortcuts, but the key thing is to spot that the power of 0.5 means to the power of a half, which means it's the square root of 25, and then that gives you the 5. And then dealing with the power of minus 2, I've gone that way. You could have at that point written it as 1 over 10 squared, rather than keeping the minus 1 on top. You'd still ended up with the same thing. 1 over 20 is what you were looking for. Number 20. Okay, so what we've got here is we need to evaluate the square root of 8 squared. Well, the square root of 8 I can write in index form as 8 to the power of a half, which I'm going to square. when I'm raising a power to a power, I'm going to multiply, and half times 2 is 1, so it's 8 to the power of 1, which is 8. Okay, so basically what you're doing is you're squaring the square root, and if you're squaring the square root, you're just undoing it. So that becomes 8. Number 21, 2 to the power of minus 2. Well, the minus is telling you it's 1 over, and then the 2 is telling you that it's 2 squared, which is 4. Then number 22, we get 7 to the power of 0. Now, that's one of the remaining laws of indices that we need to cover, if I can find my general list, which is anything to the power of 0 is 1. Okay? And the reason for that is if you think that we've got x squared divided by x squared, for example, well, when you're dividing, you're going to be subtracting the powers, so that means x to the 2 take away 2, which is x to the 0. When you're dividing anything by itself, you always get 1. So x squared divided by x squared, you know, is 1. Which means anything to the power of 0 must equal 1. So as far as this is concerned, that's just another fact you've got to remember. 7 to the power of 0 is 1. And then the very final question, which is an overlap with rational and irrational numbers. What we've got here is x to the power of 3 over 2. Now, a rational number is a number that can be written as a whole number or as a complete fraction. So in order for this to be rational, you need to have a square root of something which is going to give you a whole number. So if you chose x to be 3, well, the square root of 3 you don't know in your head, so it's going to be a decimal number, so that's going to give you an irrational answer. So what you want is any square number. Okay, so any square number. So 4 is a square number because the square root of 4 is 2. 2 cubed is 8. It's rational. If you chose 25, the square root of 25 is 5. 5 cubed is 125. It's a square number. Okay, so any answer like 4 or 1, square root of 1 is 1. 1 cubed, 1, 4. 9 would work because the square root of 9 is 3, etc., etc., etc. So any value that you pick from the list of square numbers will give you the correct answer there. Okay, so those are the laws of indices.